Hey guys, when it comes to 100 megawatts plus solar energy storage plants, should you go with AC coupling or DC coupling? Most of you probably say AC coupling, right? Well, that's just because AC systems are what we've always seen. But honestly, that's not always true. To answer that question, let's first look at what DC coupling and AC coupling actually are. With DC coupling, power from your solar panels flows through the MPPT into the DC bus and then charges the batteries directly. Simple. With AC coupling, solar energy is first converted to AC by the inverter aggregated on the AC bus, and then the PCS rectifies it back into DC to charge the batteries. So where's the real difference? It all comes down to where the solar energy is aggregated, on the DC bus or the AC bus. What makes DC coupling so good? First, efficiency. With AC coupling, you need 2 extra conversion stages, DC to AC in the PV inverter, then AC back to DC in the PCS. This typically adds around 4% in additional losses. So DC coupling is generally over 4% more efficient at charging. Then there's cost. Since DC coupling keeps everything on the DC side, you don't need AC combiner boxes or even those expensive megawatt scale transformers. Less gear means lower costs. So when should you use AC coupling and when should you choose DC coupling? Back in the day, when installed capacity was relatively low, most of the power was fed directly to the grid or consumed on site. In that context, AC coupling was the natural choice. A PV inverter was all you needed. Second, if you already have a solar plant and want to add storage later afterwards, what we call retrofitting, AC coupling is the practical choice. Third, in regions such as China and Europe, solar penetration continues to increase rapidly. As a result, midday electricity prices are hitting zero or even going negative. In this scenario, it makes sense to store excess solar generation during the day and use it later during the evening peak. That's where DC coupling shines, like I said, higher charging efficiency. Fourth, consider remote areas with no grid connection. You're building an off-grid plant to provide 24/7 power. You have to store daytime solar for night use. Again, DC coupling wins here. Better efficiency, lower cost. No-brainer. Now, let's talk about those huge 100 megawatts plus plants specifically. Why did we always use AC coupling for these before? Historically, large-scale plants fed power directly to the grid, and storage was added later as a separate system at the substation. That's the classic AC coupled architecture. But now, look at overseas ports and mines. They need large-scale off-grid systems, sometimes 100 megawatts or more, to power entire sites around the clock. They need to save daytime solar for night use. For them, DC coupling is the clear choice on both efficiency and cost. Just a heads up, with DC coupling, storage is distributed alongside the PV arrays. For example, in 5 megawatts/10 megawatt hours blocks. Traditional AC coupling, everything is centralized at the substation. That's the big difference. For these giant plants, the efficiency advantage isn't just 4%, it's over 8%. Why? Look at the diagram. DC coupling requires only 1 transformer, while AC coupling needs 2, one for the solar side and 1 for storage. Those extra transformer losses account for another 4%, bringing the total efficiency gap to over 8%. Cost-wise, DC coupling reduces your transformer and ring main unit (RMU) costs by roughly half. When it comes to 100 megawatts plus plants, the advantages in efficiency and cost are overwhelming. DC coupling is absolutely the way to go. At Gigawatt Time, we've launched our 1000 volt 60 kilowatt and 120 kilowatt MPPT controllers, plus a 1500 volt 320 kilowatt unit. They are all in mass production and ready to ship. We focus specifically on DC-coupled solar energy storage systems. We design our own MPPT, BMS, and EMS tech in-house. We also sell individual MPPT controllers and hybrid energy storage systems. Feel free to reach out to us for a quote. Follow Gigawatt Time for more practical insights. Thanks for watching.